In this video, we're going to be going over packets and frames as part of the networking fundamentals section in the Intro to Cybersecurity walkthrough on TryHackMe. We've actually already gone through a number of these, so if you're further behind on this, you can check those videos out in the playlist linked above. However, we're just going to jump right into it. So in the last video, we were going through the OSI model, and we were actually introduced to packets using this graphic that we're looking at right now with the cute puppy. The final file is the full picture of this adorable puppy. However, it was divided in transport into little packets, and each packet, as you can see, covered a segment of that picture. There's a table here I think that is important to zero in on, especially while you're doing this walkthrough. It includes a header and a description of the header that you will find on packets. Here you have time to live, which sets an expiry timer for the packet in case it doesn't make it to the destination. It includes a checksum, which provides a level of integrity for the packet. It also includes a source address, so that way the destination knows where this packet is coming from. And it also includes a destination address, so that way it knows where it's going to. Now, a difference between packets and frames. A packet contains IP address sourcing information, so it knows the destination and it knows its source. A frame, however, doesn't have that information. In the last video, we were also introduced to TCP and UDP, and as a quick review, TCP stands for Transmission Control Protocol, and UDP stands for User Datagram Protocol. So we've talked a little bit about what TCP is, but how exactly does it work? Well, TCP is a protocol that you would want to use. It basically ensures that data will make it to its host. This, however, does make the flow of information slightly slower because with every packet being sent, there is a confirmation that it has been received. One thing that you should be familiar with, though, of course, to be able to catch whenever this is happening live on your network, whenever you're running something called Wireshark or like Wireshark, is the TCP Three-Way Handshake. This is basically how two machines are able to initiate a conversation between one another. And we see here we have the graphic that shows the TCP handshake between Alice and Bob. Alice initiates the conversation by saying SYN, or by sending a SYN packet. And then Bob responds by saying SYN ACK, basically acknowledging the SYN packet that Alice sent. And then Alice acknowledges that and fires an ACK packet back. So altogether, we have three different things that occur. It is a three-way handshake. After that, they're able to share whatever data they need to, and then have the conversation that they need to have, and then they close that conversation. That conversation is closed whenever Alice or Bob sends a FIN packet, and then Bob acknowledges the FIN packet and then sends a separate FIN response, and then Alice acknowledges Bob's FIN. And then at that point, the conversation is over. Pretty simple, right? Well, you can actually practice this in TryHackMe. This includes a flag, and I'll let you go ahead and find it for yourself. But now let's go on to User Datagram Protocol, or UDP. Unlike TCP, UDP doesn't care. UDP lives its life. UDP sends all kinds of information regardless of whether or not it is received. A term to keep note of is stateful and stateless. TCP is stateful because it maintains the integrity of the session and it tracks that everything is being received. UDP, however, is stateless. It doesn't track that. It literally just spurts out information. Because it just kind of sends information, it's much faster. However, that might lead to unreliable data reception. In this graphic, you can see that Bob sends a request to Alice for information, and then Alice sends the response directly to Bob. Alice doesn't exactly check to see that Bob received any of those responses. They're just gonna be there. To wrap up this room, we are introduced to ports. Now, what exactly are ports? We know IP addresses from the last room in the networking layer. And basically, an IP address is a unique networking address that each computer has. The device that you're watching this video on right now has an IP address. But how exactly does your device know which data is supposed to go where, which program it's supposed to be received from, what kind of data it's being received? After all, it doesn't just open up a giant collection bucket and just received all data as one, kind of thing. It actually organizes the data by what's called ports. And there are actually very common ports, and there's a table here showing some of those right now. For instance, there are 65,535 ports on your device right now. Not all of those are open, but there are several common ones that you should be aware of. For instance, port 21 is for file transfer protocol, commonly used to share files between two devices. Port 22 is a common one that you might already be familiar with, and that's for secure shells. Port 80 and port 443, that's actually how you browse the internet. Hopefully you're not using port 80 so much because that is the unencrypted, that is just HTTP. HTTPS, however, is done on port 443, and that is more secure. You're probably watching this over port 443. There are several other ports that you should be aware of, but port 80 and port 443, if you're just kind of like, if you're the end user, those are probably the most common ports that you use on your device. There's a practical on here that also includes another flag. I'll let you catch that as well. So that's it for this section. And on the next section, we're gonna go to extending your network, and we're gonna learn about routers and switches and all kinds of other cool things. And that will actually finish up the networking fundamentals section on TryHackMe's Intro to Cybersecurity walkthrough. So definitely catch that. That is the top video if it is out whenever you're watching this. And if it is not out, then you can catch the playlist on the bottom and just kind of see what else we have on this walkthrough so far. With that, I'll see you all next time. Bye.